Hello.
Wow, Miss Steve.
So-
You can't just roast me like that and then start the video.
I mean, yeah.
Oh.
Okay, so intermolecular forces. Hi, I need your attention. I still need your attention. Intermolecular forces act like magnets holding molecules together. So if you think of these as the molecules, what?
Pass. Like the ball. Shut up.
So if you think of these like the molecules, and solids look like this, right? Where they're stuck together and they just kind of vibrate in place. Need your attention, folks. Vibrate in place. And liquids kind of do this, right? And then gases are like, okay, what holds them together in solids? Ooh. And the answer is, you can imagine, now this is not true, but you can imagine that there are little magnets on each of these. And when they get slow enough, because you've cooled them down enough, they can go clink and stick together. And now it's a solid. Yes? Did you have a question? Okay. Now, if I want it to be a liquid, I need to move these faster so it weakens that magnetic pull. I'm moving faster and they're like, woo, and now they can slide past each other. Now they're a liquid. If I make them go even faster, it pretty much eliminates that magnet pull. And they can go as fast as they want because now they can't attract each other. And then I slow them down and I slow them down and all of a sudden they can kind of feel that magnet. And then I slow them down even more and they can, and they stick together. Okay? All right. So we ask students to graph this. And so here is the heating curve for water. And I'm going to go ahead and let you copy, and then we're going to talk as soon as I can find my magic pencil. Found it. All right. So this says solid ice down here. Solid ice, liquid water, gas. This says melting, freezing, boiling, condensing. The x-axis is heat added, the y-axis is temperature. And then the 2 points on the graph are 0 degrees and 100 degrees Celsius. So get this reproduced and then we need to talk.
Are we in trouble? Yes.
Yeah.
Oh, is that what your mom says when you're in trouble? We need to talk.
Yeah.
Oh my God, that is what my mama said.
Yeah.
Whenever I hear that, I know I'm in trouble.
Yeah. Guys, whenever you grow up, that's what your girl's going to say too. Sorry. We need to talk.
Yeah, I've definitely. It's just a conversation.
I've never heard her told me that before.
There's nothing in between. Just sleep
I
on
will say
the
that's
couch.
my boyfriend. He started crying because I was breaking up with him.
Oh.
That's how much power I have over him.
Oh.
No.
Oh,
See,
God.
that's a halo. That's a halo on my feelings. You would think you go break up with your business.
They just start crying.
Right, more. Speak of your emotions less.
What if we already finished and now we want to be emotional?
You didn't talk about girlfriend thing. We need to talk.
Well, we're going to have a talk in a minute.
I don't want my mom to be no.
It says heat. That's really not a curve. It's more or less a diagram.
It's just a curve.
It's just lines. I don't see any curves.
It's a curve.
Sorry, where's the curve?
Zigzag.
It's right there. Yo, I got it.
Yo, I don't remember the letter Z being in there.
All right, so if you didn't notice, are y'all done? Okay. Sorry? The tiny green? Roark. It says melting, freezing.
Okay.
Oh.
Oh, yeah.
I'll go with the whole. No. It looks like no time.
And then the other one is boiling, condensing.
Yeah.
Especially.
It takes a while, but then it's fine.
Okay. So we just talked about the intermolecular forces. Those forces, you could think of them like magnets attached to every molecule. Some magnets are super strong, some magnets are super weak. But no matter how strong or how weak, if you add heat, it weakens them further. And so I don't know if you've ever thought about this, but how weird is it that in this room is the same temperature, right? This room is 72 degrees. How weird is it that you have a solid and a liquid and gas that's in the air, and it's all the same temperature? Because don't things turn to a gas when you heat them up, and then things turn to a solid when you cool them down? So how is it that we have solids, liquids, and gases in this room right now that are all at 72 degrees? And the answer is that some molecules, like the molecules of this desk, have super strong magnets. And so they stay together even when heated up. You have to really heat them up to get them to liquefy, to get them to melt. Liquids, like that water right there, they have moderate magnets. So at room temperature, their magnets are weak enough to let them do this. They don't get too far away from each other, but they're still able to fly around each other. Sorry? Yes, so it's liquid. Now, if you wanted to heat it up even further, it would weaken these weak magnets more, and so then they'd be able to fly apart. And then gases don't have magnets at all. And so no matter how close they get to each other, they're just like, yeah, they fly apart. Okay? So that's why you could have solids, liquids, and gases, and all of them be the same temperature, because different molecules have different intermolecular force strengths. Now, it's not true magnets. I don't want you to think of it like that. It's not a true magnetic force, but it's close enough for you to be able to visualize. So what kind of intermolecular force do solids have? Strong. Very strong, like strong magnets. And then liquids have moderate intermolecular forces, medium, and then gases have none. What do I need to do to weaken intermolecular forces? What if I want to melt a solid? How do you weaken those magnets? By adding heat. And that makes them move faster, and that makes those magnets not work as well. Questions on that? Because it's kind of important you get that concept. Are they real magnets? No. But they're areas on the molecules that act like magnets. Okay? Okay, so let's talk about this. Why does this heating curve get flat in some areas? That's what we need to know. Well, I have right here a thing of water, and I set it on a heating pad, thank you, hot plate. Got heating pad on the brain because it's cold outside and I would rather be at house.
Yes.
Lordy, lordy, lordy.
Go back to English.
Can you go back to your house and read English?
I need to be back at the house. I need to go house. Okay. And so what I've done is I've started the heat on this. I've put it on the heat just a few minutes ago. So it's going to take a while for it to get to boiling point. Okay. Right now, it's at 30 degrees Celsius, which is room temperature. Right about room temperature. So it's been warming up. And it's going to take a while to boil. But I'm going to spoiler alert you and tell you that I cannot get that thermometer in that beaker to go above 100. I'm going to make that water boil, and that thermometer will not go above 100. No matter how long I leave that boiling water on there. Yeah. Why doesn't it go above 100? That's what we need to talk about. So what is happening? Right now, where am I on this graph?
Right now, you're
Good. I'm right about here-ish, right? I said 30 degrees, so maybe right about here-ish, right? And that dot's going to go up and 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 up until it reaches 100. And then it's going to stop going up. You're going to continue to add heat. I'm going to still leave it on this hot plate, but the temperature's not going to go up. Yeah. It is going to be turning into a gas, but why does the temperature not go up? And let me tell you why.
I'm just trying to recall here. I'm interested. But isn't there a word that it is? Never mind.
I'm sure there's several words. Okay. So, what is happening to the molecules? All right, you ready? What does this look like right now? If I were to zoom in on those water molecules, what do they look like? They have moderate magnet things, right? So they're attracted to one another, but they're moving fast enough that they're kind of able to overcome that magnet force and then snap back and then overcome. And so they're able to move, but not far away from each other because that magnet won't let them, right? All right, so when that's liquid. In order to get to gas, what do I have to do to these magnets? I have to weaken them so much that the water molecules are moving too fast for it to hold. So the heat energy that I'm going to be pouring into it right here does not go to making them faster. It goes toward making those magnets weaker so that they can go faster. And then once all of the ice is gone, then the temperature can go up. Excuse me, I didn't mean ice, I meant water. Then once all the water is gone, then the temperature can go up. So, let's see where this dot is now. It's about at 35-ish, so it hasn't moved far. No, not the whole thing. I didn't want the whole thing. Man, I thought I could just move the dot. I will. All right. So we're about here. And I'm going to keep track of this thing as we go. All right. Now, the same thing happens with ice. If that were ice in there, let's say I took it out of the deep freeze. I put a thermometer on it. It's at negative 10 degrees. I let it sit on that hot plate. It would get warmer, 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 warmer. It'd still be ice, no water, until it hit 0. And then you start to see those first water droplets come off of it. When that happens, that temperature is going to stop going up, and it's going to stay at 0 until all the ice is melted. And I was planning on doing that today, but with the ice outside, I couldn't get here in time to set up the ice inside. So that didn't happen. So I'm just going to do this one here. But the same thing happens.
Do you think that we're gonna have a happy?
So let's talk about this right now. All right, so when I am going from solid ice to liquid water to gas, am I putting heat in to go up or am I taking heat out? And what's that called? In is endothermic. So as you're moving up this curve, this way, is endothermic. You're putting heat in. Mhm. Now, in order to go from gas to liquid to solid, you have to let the heat exit, right? So exothermic. And then this is the test question. Well, actually, those are test questions too, but this is another test question. What is physically happening here and here? What is happening to those molecules? Why does the temperature not go up? Heat weakens the intermolecular forces during phase changes. It doesn't make the temperature go up because it's busy weakening those forces. And I'm at about 45 right now. I will in just a second. Oh, like that?
Oh, no, I just need to see what the word on top of the other arrow.
Okay. So when the test asks you what happens during those flat spots, what are you going to answer? Why is the temperature not going up? What is the heat being used for instead? Weakening the intermolecular forces. And so normally when you add heat, that energy makes the temperature go up. But during phase changes, it doesn't make the temperature go up. It makes the intermolecular forces weaker, so the temperature can go up later. So that's what the heat is being used for. All right, questions on that? I would strongly suggest that you put this on the note card because it is going to ask you to label on the test. It is going to ask you to label all of these points. It's going to these points are going to be labeled A, B, C, D, E. And it's going to say what is happening to the heat between A and B. If heat is added at point B, what will happen? And the temperature is going to go up is the answer. So I've given you a practice that gives you those example test questions, but you are also going to have to label this whole thing. Are you clear about the expectations on the test for that? Okay, so I've printed out a review for you. Because there will be a test on Friday if we're here. So even if you're home, I need you to do the review. What if you have a question on the review and you can't do a question, you need my help?
We can text you.
You can text me, so please do. Okay? I will be at home, probably watching Netflix, and I'll be happy to answer any questions that you have. And when I say happy, I will mean thrilled to be bored out of my mind. Yes?
What if I want to watch Netflix and not do it?
You have that choice, Lucas. I just want to encourage you to think about retaking chemistry.
Oh, I'm out of here next year, bro. I'm not staying.
All right, so we're going to monitor this water, and I promise you I will not be able to get this thermometer to go above 100 degrees. Don't believe me? Try it yourself. Goodbye.